Good day, viewers. This is Afia Demola Johnson, your science tutor. We are here again to continue our work on functional groups. Please do not forget to subscribe, like, and share these videos. I also want to tell you before we continue, we have started our physical lecture for POSUEMI, for JAM, for WAEC, NECO, entrance into nursing schools, examinations, all kinds of preparatory examinations we have started, and that lecture holds by 5 to 7:30 p.m. so that people can go to their work and come back and learn. Not that learning will take the hold of their work, and so we don't want people to become useless because they are learning. So God bless you. This is, and the venue of the lectures is Christ Rock Academy, Saple Road, kilometer 8, Tuta. When you are coming from Main Road, if you get after Ajib, then you are coming to Ekai. In Ekai, ask for Tuta Junction. So when you get there, ask for Christ Rock Academy. There is 24-hour solar system light there, and the environment is conducive. God bless you. Let's continue. We want to talk about, don't forget, in our previous class, we talked about alkane, alkene, alkyne, alkanol, then alkanoic acid. So now we are going to alkanoates, name of homologous series. Name of homologous series. Then general formula of homologous series. General formula. Okay. Let me so I can. General formula. The functional group. Then the next thing to look at is suffix name. Suffix name of the functional group. Then the next thing is prefix name. Then example. So, well, with alkanoate. Alkanoate is also known as Ester or Ester. Alkanoate or Ester. The general molecular formula of alkanoate is RCOOR prime or RC. This O, one of these two oxygens can join to this carbon with a double bond, and the bond will come here and join this OR prime together. So don't forget here that your R is an alkyl group, can be an alkyl group. An alkyl group whose molecular formula is CN H2N plus 1. So sometimes R can also be hydrogen. Can also be hydrogen atom. So then your R prime can also be alkyl group. Can be alkyl group, which is CN H2N plus 1. It can also, R prime can also be metallic or ammonium ion. can be metallic or ammonium ion. Now, then the functional group of this is what? Remove the alkyl group. What you have is COOR prime or COOR prime. That's the functional group. And the suffix name, don't forget the last three name, 8, O8, I mean 4 letters, 1, 2, 3, 4. So that is the suffix name, O8, O8, O8. Now, O8 group. While the previous name is dash. Now let's look at a common example. Let's assume that your R now, okay, here now, another way of writing this, knowing that R, it can be Cn H2n plus 1, then you have COO, another Cn H2n plus 1. Let's assume that your N here is 2 and your N here is 1. So if you put 2, you want to follow this formula. If your N is 2, rewrite this C as C. Then instead of N, put what? Put 2. Then there is H there in the formula before. You have the H. Then 2 times 2, that's 4. The 4 plus 1, that's 5. Then you have what? COO. Then, okay, let me COO. Then you say let N be 1 here. C1. No need of putting the 1, don't write C. Then H. 2 times 1, 2. 2 is your answer here. Then that 2 plus 1, that's 3. Now, you can rewrite this. This is molecular formula. You can rewrite it as structure. What you need to do is that you can break that carbon atom into 2. You can break the carbon atom into 2. You can have C, second C, to represent these 2 carbon atoms. Then you attach 1 hydrogen here, 1 hydrogen here, hydrogen here, 1 hydrogen here. Then the second one is also 1 hydrogen here, 1 hydrogen here. Then this one is joining to this carbon, this one, and this one can be bonded to oxygen up and coming down. The second oxygen is here. Then this carbon is this, surrounded with how many hydrogen? 3. 1, 2, 3. So you have it like that. You can see, you know, this one is or. Then another way of writing this is condensed formula. This one can be C, this carbon C. How many hydrogen is surrounding it? 3. Can be CH3. Then you come here. How many hydrogen? 2 hydrogen is there. Then you have what? COO. Then you have what? This is the first C. This is O, another O. CH3 is surrounded with 1, 2, 3. Now, to name this compound, before that, you can see have what we call bond line notational formula. Bond line. A kind of formula that is usually in form of zigzag. Zigzag. And it only shows, now let's look at this. If I draw something like this, I'm only showing this bond line. And this carbon is at this tip. These 3 hydrogen are imaginarily supposed to be here, but they are not. Hydrogen is not part of bond line notation. That is the method adopted in drawing the structure of benzene. So then this carbon is this tip. This carbon is this tip. Now to join this carbon now, we need to draw a line to represent this bond. Then this carbon now is here. So this double bond now can put it like this, and this oxygen is what? Is like this. Now this bond can take it down. This oxygen can come like this, and a bond like this. This bond is representing this. Then this carbon is this thing. There are 3 hidden hydrogen out of there. That's the bond notation for this compound. Now to call this, to give it the IUPAC name, what do? Now, first of all, know that this COO is separated to alkyl group. This alkyl group is methyl group. When it is 1 carbon, it's methyl. When it is 2 carbon like this, 1, 2, ethyl. When it is 3 carbon, propyl. When it is 4, butyl. When it is 5, pentyl. When it is 6, hexyl. When it is 7, heptyl. You can visit the previous video we had done about alkyl group and functional group. You will find it useful there. Now, identify that this is methyl, this is ethyl. Now, identify which of this one and this one is alkyl group and which one is alkyl prime. The one that is the alkyl group is the one that, the alkyl group is the one that is joined to the carbon bearing the double bond to oxygen without any oxygen bridge between it. While the one that is first of all joined to oxygen before joining to CO is the alkyl prime. And the rule is to first of all call from the alkyl prime. If you have 1 carbon atom with the alkyl prime, call it methyl. Like you have here now, methyl. Then after doing that, next thing, now count the number of carbon remaining. This is supposed to be ethyl group. Ethyl plus 1 carbon from the functional group make it propyl. When it is still is propyl now. But if the number of carbon you have here is 1, maybe the whole of this thing is hydrogen. You know, I told you the alkyl can be hydrogen atom. If it is hydrogen atom that is representing these 2 carbon, then it means that there is only 1 carbon here. Then call it metanoate. That is, what do we mean by metanoate? You will call it the name of the alkyl group, the name of the alkane member that has this same number of carbon, and replace the E ending that name with OH. So you know that the first member of alkane is methane, the second member of alkane is ethane, the third member of alkane is propane, the fourth member is butane, the fifth member is pentane, the sixth member is hexane. But here now, we have 1, 2, 3, that's propane. Write the propane. Now replace the E ending the propane with OH. Then it becomes propanoate. It becomes propanoate. That's what you have there. Propanoate. So that is that. That's methylpropanoate. Can you try this one for me? So, can you try this one? CH3 COO. Then you have CH2 CH3. Can you try this? So what we have here is what? Now, look at this. This is the alkyl prime, because between it and the carbon bearing double bond to oxygen, there is oxygen atom between them. So you start, and when you have 2 carbon, call it what? Ethyl. Then, how many carbon do you have left? 1, 2. Now, call the name of the alkane group with 2 carbon atom is what? Is ethane. Then replace the E with OH. It becomes ethyl ethanoate. Don't forget I told you that this one can even be hydrogen. Then we can have CH2 3 CH3. What do we mean here? This is another thing. CH2 appearing how many times? 3 times. So this one is a way of saying it's a way of doing something like this. CH2 C is a way of doing something like this. 1 2 3. Surrounded with 2 hydrogen, surrounded with 2 hydrogen, and surrounded. So if instead of repeating CH2 CH2 CH2, you can just pick only one of them and put 3. See, they occur 3 times. So that is what we have there. So this CH will occur 3 times. So there are 3 carbon atoms there. 3 carbon plus 1 carbon, that's 4 carbon atoms. The name of alkyl group with 4 is butyl. Butyl. Now, how many carbon do you have here? 1. The name of alkane with 1 carbon is methane. So then replace the E with what? With OH. It becomes butyl methanoate. Can somebody try this for me? Now, I'm about to give another one. I also told you that this whole thing can be a metal. What if you have something like this? ONA. Can also have something like this. Now, this one now, you start from this one becomes sodium. How many carbon? 1 carbon. Methane. Then replace this one with what? OH. It becomes sodium methanoate. Sodium methanoate. I said it can be a metal, metallic ion, and it can also be ammonium ion. What if I have CH3 C O then I have NH4. So what is the name of this one going to be? This will now be ammonium 1,2-ethanoate. So that is that. So that is all you need to know about the alkanoate molecular structure, general formula, the functional group. So in the exam, you can be given a compound like this. They say, name the functional group in this compound. The functional group result is COOR prime. That's what we write out. And you see it's what or Ester functional group. Now let's go and look at ether. Ether. So now number 9 is ether. Look at the spellings. ETHER. The other one was Ester, no H inside. But here now you remove the S and put T and add H. That's ether. If you don't call it ether, you can call it alkoxyalkane. Alkoxyalkane. Or you call it alkyl, alkyl ether. alkyl, alkene, ether. These are the three names. We call them ether, alkoxyalkane, alkyl, alkene, ether, or you call it dialkyl ether. Or you call it, since it's the same thing as here, dialkyl ether. Dialkyl ether. The general formula of ether is RO, another R. Don't forget, we said functional group is the number of carbon atom, carbon to carbon covalent bond, the number of atom or a group of atoms. So here now is in the case where you have an atom of oxygens in between two alkyl groups. Don't forget the alkyl group can also be CN, A2N plus 1. Then you have oxygen between them. You have another CN, A2N plus 1. Now, the R is what? Alkyl group. So, it can also be a metal, a metallic, a metallic atom, like sodium hydroxide. So that's alkoxide. Okay, so this can also be what? Alkoxide. When it is better, alkoxide group. Now the functional group is just the O in between the two alkyl groups, the O, the oxygen there. Then the suffix name, nothing like that, nothing like prefix, but let's look at common examples. Now, common example, let's have, if the formula is ROR, or the formula is CN A2N plus 1 O CN A2N plus 1. So let's say N equals to what? Let's say N is 1 here, N is what? 2 here. What do we do? Put 1 here. Instead of you have C already. This one is what? You don't need to put the 1, but you can write this H. Then 2 times 1, 2 plus 1, that's 3. Then put your bond and put your functional group oxygen. And come here, write this carbon. Instead of this N, put what? Put 2. Then write this H back. Then 2 times 2, 4 plus 1, 5. This is a molecular formula. You can rewrite this as a structural formula. 1 carbon surrounded with 3 hydrogen atoms. 1, 2, 3. 3 hydrogen, this 3 H is this 1, 2, 3. Then this is joined to this oxygen. Then you can tear this carbon into 2 parts. 1, 2. Then if you do that, 1 hydrogen is here, 1 hydrogen is here, 1 hydrogen is here, 1 hydrogen is here. Oxygen must be surrounded with 2 bonds. Why? Oxygen is number what? Hydrogen is number 1, helium is number 2, lithium is number 3, beryllium is number 4, boron is number 5, carbon is number 6, nitrogen is number 7, oxygen is number 8, and the configuration for oxygen 8 is what? Is 2 to 6. So because of that, for it to form oxide ion, it borrows 2 electrons to add to this 6. So because of this valency of 2 minus, oxygen atom will be surrounded with what? 2 bonds. That's what you are seeing here. Now another formula for this is the condensed formula. You can write your C, then the 3 hydrogen can be represented as what? H3. Then you have what? O. Then here is what? CH2. And this one is what? CH3. Then you can still use bond line rotational formula for this. How do you do that? You have a stick to represent this CH3. See, there's a carbon here, there's an imaginary 3 hydrogen atom there. Then this line that joins this, okay, this is a line now, this is a line. So the oxygen is here. Then this oxygen now, this line, this carbon is this tip. Then we take it down. So this carbon with 2 imaginary hydrogen. Then this is a carbon with 3 imaginary hydrogen. That's the bond line notation for this. Then how do we call this compound? There are 3 types of calling it as stated here. Let's do the first type. Alkanoate style. Alkanoate style. It means that whatever thing that is here, you call it alkane and you blend it with oxygen. If it is 1 carbon that is here, you call it met-oxy, that is methyl and oxygen. Met-oxy is 1 carbon. If it is 2 carbon, you call it what? Et-oxy. If it is 3 carbon, prop-oxy. If it is 4 carbon, but-oxy. If it is 5 carbon, pent-oxy. If it is 6 carbon, et-oxy. Like that. So, but here I have 2 carbon. I will call it what? Et-oxyl. Then what carbon is here? 1 carbon. You don't call it the name of the alkane. You can say alkoxyl, alkane. If it is 1 carbon that is here, methane. Although it is methyl, methane is CH4, but this is CH3, which means methyl. But the system says you should call it alkane. Despite the fact it is a member of alkane, but call it alkane. So it now become etoxyl methane. Then what about if you have something like this, CH3O CH3, which you can rewrite or now you can rewrite this one now or as what? Carbon, 1 hydrogen, 2, 3. Then oxygen, 1 hydrogen, 2, 3. Then the bond line notation, you can just have something like this. Finish. Now, this one, so this is the first style, methoxy methane. You can still use another style, alkyl ether. That is, you say, what is the first alkyl? This one is what? Ethyl methyl ether. Or, you start from the back here. When it is 2 carbon, that's ethyl, that is here. Then this one is methyl, then ether. So you have ethyl methyl ether. So this one also, since it's the same CH3 that is here, you can use the word dimethyl ether. If it is ethyl become diethyl ether. Then you can still call it what? Or met-oxy methane. So that is met-oxy, this is methane now. So that is that. Okay, etoxy methane. So now, so what about, you can say it is what? Methyl ether. What about this one? Who will try this for me? CH3, CH2O, Na. So when you have this one, this is the 3rd case when you have alkoxide group. Alkoxide. So what do? This one you can see write this one as 1 carbon, 2nd carbon. Around this carbon there are 3 hydrogen, 1, 2, 3. Around this one there are 2 hydrogen, 1 up, 1 down, 1 up. Then there is oxygen here. Then you put your what? Na. Then bond line notation can be what? Na. So this carbon is this tip, this line is this line, this carbon is this corner. Then this line is this line. This oxygen is this oxygen. This line, this bond is this line. And this Na is this Na. So what do you do here? Call the metal first. This is sodium. Sodium what? How many carbon is here? If it is one carbon atom that is here, it becomes methoxide. If it is 2 carbon, ethoxide. 3 carbon, propoxide. 4 carbon, butoxide. 5 carbon, pentoxide. 6 carbon, hexoxide. But what we have here is what? Ethoxide. Now becomes sodium ethoxide. Sodium ethoxide. That's what you have there. Sodium ethoxide. Sodium ethoxide. That's what you have there. So that is all we need to explain about ether. If you have any question, you can drop your question in the comment section and it will be treated appropriately. Let's move on from here and look at another homologous series apart from ether. Let's go to alkyl halide. Alkyl halide or halogenoalkane. Alkyl halide or halogenoalkane. Now, number 10, we have alkyl halide or halogenoalkane. That's another homologous series. Now, this one, the general formula is RX, X, where R is an alkyl group whose formula is CnA2n plus 1. So the general formula can still be rewritten as what? Cn. So the general formula can still be CnA2n plus 1x. Then what is S? Where X is halogen. Halogen atom. And halogen means group 7 elements. So it means X can be chlorine, X can be bromine, chlorine, bromine, Br, chlorine Cl. It can be S, can be fluorine, fluorine F. And S can be what? Iodine. Iodine I. Now, the functional group is just X. When you remove the alkyl group, the remaining thing you have is the functional group. Then the surface name is what? If you are using the first type, halide, can be, the surface is halide. Halide group. That halide group for chlorine, it will be called chloride. Chloride. For fluorine, it will be fluoride. For bromine, it will be bromide. For iodine, it will be iodide. Then prefix name is halo group. For chlorine, chlorine will be chloro group. Chloro. And then bromine will be bromo. Then iodine will be iodo. Fluorine will be fluoro. So these are they. Now, let's assume that when the formula is CnH2n plus 1x, You can decide, let's say our N is 5 and our X is chlorine. Then put 5 here, you have C5. H 2 times 5 is what? 10. That 10 plus 1 is 11. Then I have Cl. Now, this is molecular formula. We can as well get the structural formula. Tear this 5. 1, 2, 3, 4, 5. Put single bond. Now, if your chlorine is by the first carbon or the last carbon, if your chlorine is by the first carbon or the last carbon, then its name ends what? Then you have, what do you have? You now count the number of carbon 1, 2, 3, 4, 5. So it becomes that's pentyl group. Now, so the name now becomes for the name of that's pentyl chloride. Pentyl chloride. Pentyl chloride or 1-chloro now or 1-chloropentane. So it depends on you. One in the sense that this is carbon number 1 here now. You start counting from here. Because the rule says while numbering, it said the lowest possible number should be given to the carbon atom having bearing the functional group. If you start numbering from here, you have this is 1, 2, 3, 4, 5. But if you start at 1, 2, 3, 4, 5. So out of 5, which one is small? 1. So you start numbering from the side that will give this carbon bearing this functional group the lowest number, not the biggest 5. So that's why we have 1-chloropentane. If it is iodine, it becomes 1-iodopentane. If it is fluorine, 1-fluoropentane or pentyl fluoride, pentyl iodide, and so on and so forth. Now, let's move on to another thing here. Another way of writing this. Another ways of writing this is the condensed formula. This is CH3. This is CH2. How many CH2 have? CH2, CH2, CH2. How many of them? 3. This is CH. Okay, even 4. You can put CH2. 4 of them. Then I have what? Cl. So the bond line notation will now be what? 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This carbon, or I can start from here like this. 1, 2, 3, 4, like this. I can start like this or like this. So this carbon is this carbon. This line is this line. This carbon is this carbon. This line is this line. This carbon is this carbon. This line is this line. This carbon is this carbon. Okay, this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This carbon is this carbon. This line is this line. This carbon is this carbon. This line is this line. This carbon is this carbon. This line is this line. This carbon is this carbon. This line is this line. This carbon is this carbon. Then this line that joins it to chlorine now is this line. And this is the chlorine. So the same thing here. This carbon is this carbon. This bond is this line. This carbon is this carbon. This line is this line. This carbon is this carbon. This bond is this line. This carbon is this carbon. This bond is this line. This carbon is this carbon at the tip. Then this line now is this line, and this chlorine is this. So either of these is a bond line notation. Take note of that. So let's look at another group here. Number 11. Now this one is called carbonitry. Me, I used to call it alkanoate. Alkanoate, based on the style, but I've not seen this in a textbook before. But personally, I call it alkanoate. Now, that is alkanoate. In his own case, his general formula is C with triple bonded to nitrogen. And you know this R is same thing as well, Cn, A2N plus 1, then C triple bonded to nitrogen. That's that. So the functional group now is going to be C triple bonded to nitrogen. So that's the functional group. Now the surface name, look at the name, onitri. So that's onitryl group. That is his functional group name, onitryl group. Now, if that is it, then the suffix doesn't have. Now, let's look at the example. If the formula is Cn A2N plus 1 C triple bonded to nitrogen, let our N be what? Let me just put 3 there. Now, if I put 3 in place of this N, I have C3, I have H, 2 times 3 is what? 6 plus 1, that's 7. Then I have triple bonded to nitrogen here. Now, then I can rewrite this structurally as 1, 2, 3 for representing this carbon. Then 7 hydrogen. 1, 2, another hydrogen, 3, 4, 5, 6, and 7. Then there's a bond that joins into this carbon with triple bonded to nitrogen. So what I have there, now I can do what now? The condensed formula cannot be what? CH3. C surrounded with 3 hydrogen. Then here I have what? CH2. How many CH2? I have 2 of them. I can put them inside bracket and put 2. Then I have what? C triple bonded to nitrogen. Now, the condensed formula will not be what? Either this 1, 2, 3. This carbon is this carbon. This line is this line. This carbon is this carbon. This bond is this line. This carbon is this carbon. Now, then this line is this line. Then it's triple bonded to what? To nitrogen. So you have it there. That's it. So either you take, or you can take it like this. This